Okay, so the first test we have to discuss here, it is chi-square test, right? So what is the chi-square test now? And in this chi-square test, we have to consider the first test, which is called as the test for. Okay, I will just think the small pen is better. Yes. So test for goodness of fit. Okay, goodness of fit. That means how to do the fitting on the basis of this chi-square test, right? So this thing we have to discuss, right? Since that what they are doing. So firstly, we are considering there are some observed frequencies are there, right? So which is denoted by O1, right? So here they have given firstly some observed frequencies, that is OY, which is denoted by OY. Observed frequencies they have given, where your eye is running from 1 to up to k, right? Suppose uh, consider that is they have given O1 O2 up to OK, right? These are all the observed frequencies I have, right? And also they have the expected frequencies, right, which is EI, okay, which is again denoted by EI, where I is running from 1 to up to E, okay, sorry, 1 to up to K, right? These observed and expected frequencies are there. Then what we are doing, we are setting the null hypothesis, right? So what is the null hypothesis I have? So I have H naught, that is what? So my H naught is there is no significance difference there is no significant difference between OI and EI, right? So this is my, okay, I will just capital EI is here, okay. There is no significant difference between OI and EI. That means there is no significant difference between observed frequencies and expected frequencies, okay. So this is my null hypothesis versus what will be my alternate hypothesis then? There is there is significance difference, right? There is significance difference between the OI and EI, right? So that will be your alternative hypothesis in this case, right? So this is the construction of the null and alternative hypothesis, that is there is a so no significance difference, right? When this OI and EI are same, right, then this will be your null hypothesis, and if your OI and EI are not same, then this will be your alternative hypothesis, right? Okay, so what will be the test statistics thing? Okay, so this is all we have discussed all about just about the hypothesis, right? Just we have just defined the null and alternative hypothesis, right? So what is your test statistic now? Okay, so then I will get the state statistic that is denoted by chi-square. Mm, yes. Yes, so the test statistic is what? Okay, so it is denoted by, that is therefore the test statistic is, okay, so it is denoted by chi-square. So chi-square is nothing but it is summation of I from 1 to k. Okay, oi minus ei bracket square divided by ei. Right. So this will be the test statistic in this case. Right. So that is equals to what? It is summation of I from 1 to k. Now this will become what? It is oi divided by ei. Okay, it is oi square divided by ei minus capital N. Right, where capital N is nothing but it is the total of the observed frequencies, right? Total of the observed frequencies, right? This will be your capital N in that case, right? So where I can write here, that is where capital N is means what? It is summation of OI, right? Or it is the summation of the expected frequencies also, right? So then this will follow, that is this test statistic is follow, right? It will follow chi-square distribution with the parameter that is k minus 1, right? That means if there are k observations are there, then your parameter of the distribution will be what? It is k minus 1. Okay. Now what is the critical region in this case? Yes, what will be the critical region? Now here, in this only chi-square this test, okay, in the chi-square test of goodness of fit, we are not using alpha by 2 in the case of the two-sided test, right? So here we are direct using, that is here your critical region, right? The next procedure is what? Critical region, right? So in this case, your critical region will become, it is the probability of chi-square greater than chi-square alpha, right? Which is equals to alpha. That means you have to just find the value of the chi-square alpha, right? Okay, so it is again, it is just depend on this, right? So this will be your critical region. So what will be decision then? How to take the decision in this case? Okay, again it is similar, okay, but we are just where we are accepting only alpha. We are not finding the alpha by 2 in the case of the two-sided test, right? Yes, so reject the yes not if what? When your chi-square calculated value, right, is greater than or equals to what? Chi-square table value, right? That means chi-square alpha, right? If this condition is satisfied, then we will reject yes not. Otherwise, what? We will accept the yes not, right? So this is all about this test, okay, right? Now we will just see one example now on this kind of test, okay? On this test for the goodness of the fit, okay? Okay, that means these are the given observed frequency which are given in the example, right? Digit frequency and the frequency. Okay, so that means this will be my observed frequencies. Now here what they have given you, the following data shows the distribution of the digits in the numbers chosen at the random uh, from the telephone directory. Okay, we have to test the 1% level of significance whether the digit may be taken to occur equally frequently in the directory, right? So this we have to find out. So what is your conclusion, right? What must you have to find, that is the whether the digit is occurring equally frequently or not, right? So that is the reason here we are defining the null hypothesis will be what? That is the digit occur equal frequently, and alternative is what? Digits do not occur frequently, right? Now here we are also finding. Firstly, what is our first step? We are finding the observed and expected frequencies, right? Observed frequencies are already given, right? So these frequencies are observed frequencies, right? Yes. So these are just digits, and observed frequencies are just the frequencies, okay, which we are given. How to find these expected frequencies now? We have to just divide this, okay? Divide this number by this 10,000, right? That means total number of the frequencies, right? Then you will get the observed frequencies, right? Now here we get the expected frequencies is the same for all, okay? Because here we are assuming the true expected frequency for the each digit, right? So here it is just a 1 by 10 into 10,000. So here the expected frequency of the for the each digit is what? It is the 1,000. Okay, and just do the square of that EI and divide it by EI, right? Just do the square of all the observed frequency and divide it by EI. You will get this column, and then you will get the test statistic, which is what? This summation of this minus capital N. Now capital N is what? It is 10,000, right? So it is 10,020.16 minus 10,000. Okay, so this will be your calculated value. Now table value is simple then. Just you have to check this value, that is chi-square 9 and 0.01, right? Because alpha is given, that is 1% in this case, right? Yes. So we can easily find out that value, and then we will try to compare our calculated value and the table value. Then you can see that your calculated value is what? It is lesser than the table value. So we will accept the yes not in this case. So we can say that the digit occur equally frequently again. Okay, right? So the yes not is what? The digit occurs equally frequently again, right? So this will be your, yes, this will be your null hypothesis in this case. Okay. Okay, so this is all about the test for the goodness of the fit. Now the second test we will discuss here. Okay, so the first test was the test for the goodness of the fish, and the second is the, it is the test for the checking the independency of the two attributes. Okay, that is the cascade test for the independence. Okay, so here we will see the example on the basis of this, because you will get the proper idea after seeing the example. So I will just take that example now. Now here, what will be your yes not this in this case? So always remember that. So in this case, your yes not is what? It is the, there, that is the two attributes. Now here they have given you two attributes. That is the grades, right? And the programming grades, right? Mathematics grades and programming grades. So we have to find the relationship between the mathematics grades and the programming grades, right? So I can define here the null hypothesis will be what? It is the performance of that is performance in or performance of, I can say performing in math, right? Performing in math and programming are independent. Okay, if it is independent, then this will be my null hypothesis. And what will be H1 then? Right, that is the performance of math in the programming are dependent. Right, this will be my alternative hypothesis. Right. Now these are now the given things they have given in the example will be my what? It will be observed or expected frequencies. Yes, this will all my OI. Right, that means this will be my O11. This is O12, O13, O21, O22, O23, O31, O34, sorry, O32 and O33, right? So this is all my observed frequencies. And from that I have to find the expected frequencies, right? So how to find the expected frequencies, right? That is the question, right? Okay. So firstly, I will just make one column of OI, that is observed frequencies. So you will get this. So what are my OIs, right? So OI are simply just observed frequencies. It is 56, 71, 12, 47, 163, 38, 14, 42, 85. Right, these are my all the observed frequencies. Now for finding the expected frequencies, in that case how to find the expected frequencies, right? So for that purpose I have to total, right, all these rows and columns, right, for finding these expected frequencies. Okay, so just find out this total of row wise, then I will get the first total is, I think it is 139. The second is what, 248. 141, 117, 276, and 135, right? And my total, right? That is the total sum of the frequencies will be equals to, that is capital N I get is equals to 528, right? So what I am doing, I am just finding the sum, right? Row wise and column wise. How to find the expected frequencies now? Okay. So what will be my expected frequency? Now EIJ, how to find this EIJ? So formula for this there what? So the formula is, that means suppose I have to find this. Okay, this is my what? My first column will be what? It is O11. This is O12, O13. Similarly, this will be O21, O22, O33. Now I have to find this E11, right? So what will be that E11? So it will be, now this is my A1, right? Because this is, it is A, suppose I am considering it is A, B and C. Sorry, it is A1, A2 and A3. Here it is B1, B2 and B3, right? So this will be my A1, A2 and E3, right? This is A1, A2, A3, B1, B2, B3. So what is EIJ? It is nothing but it is AI, BI, okay, BJ, right? AI, BG divided by capital N, right? This will be my formula of expected frequency. That means suppose I have to find this E11, that means this first value that is on which is on O11. So what will be that? It is sum of these two numbers, that is a1 b1. Understand? Okay, sum of this number 3191 plus 117 divided by this value, right? Okay, so same I am just proceeding here. Okay, so this will be my all the values of the EIJ. That means all the expected frequencies are here. So this is 391 plus 11756. So I will use Excel, right, for more understanding to you. Just 2 minutes. Open another sheet. Okay. Now what are my objected frequencies? Okay, observed frequencies. So it is I am denoting it by OIJ. So what are these values are given? So my first value is 56. Second is a 47. Third is 70. Okay. And my next values are what? It is 71, 163, 163, and then 42. 42. Okay, and another values are 12, 38, and 85. Right. So these are all the values which are given, right, and these are observed frequencies. So how can I find out my these are the observed frequencies? So how to find the expected frequencies? Just 2 minutes. I am just making that columns to get. Okay. So firstly, just find out the total of the rows and column. So I am finding the total here. So it will be just I am just using this. So here are the totals, right? Again the total of this. Okay, so it is covered. So this will be what? This is the total of this, right? Here it will be total of these three numbers. Okay. So I am just cross checking whether this total is also equals to this number or not, right? So for that purpose I am using the formula that is equals to what? Sum of these three numbers, right? And enter, right? And here you can get the same sum, right? Now how to find the observed frequencies? Okay, sorry, here I just want the border thick outside border. Okay. Yes, so this will be what then? So how to find the so it will be equals to what? This number, right, multiply by this number divided by the total. Enter, right? And similarly you will get all, right? This means what? It is the it is what? It is the multiplication of the this, right, into this, right? This into this divided by this, right? So this is how you get all the expected frequencies, right? And here I will get all the expected frequencies. Sorry, so here also I have to put that formula again, right? So this is equals to again what? This star this number divided by this number equals to that, equals to what? This number star number divided by sum. Okay, so similarly I will get all that value. Okay, so this is the Same thing we have to find, and then you will get the all the values here. Okay, so that is all the expected frequencies, right? So here, after doing that all the calculation, I am getting the expected frequencies. So what will be my expected frequencies there? Yes, so it is, the first is 30 point, is it same? Yes, 30.80. The second is the 72.65, then 35.53, 54.94, then it is 129.63. After that it is 63.40, then 31.24, 73.70, 36.0511, right? So this will be my all the observed frequencies, right? Now what you have to do, just use these expected frequencies, right? That means what I am do now, the next step is what? I will find the square of this all the OI square, right? So just use the test statistic now. So what is your test statistic in this case? Hence the test statistic is, hence the test statistic is, so what is the test statistic? It is chi-square. In this case it is r minus 1 s minus 1. So what is the meaning of this? Chi-square row minus 1 column minus 1. Now how many rows are there? Yes, 3 rows and 3 columns, right? So it will become chi-square 3 minus 1 into 3 minus 1, so that is 2 into 2, right? Chi-square 2 into 2. Okay, so what is the formula then? It is the double summation of Oij square upon Eij, right, minus n, right? And this will be follow chi-square distribution. That means what I have to do? I have to just take the square divided by that respective EI, right? Again this square plus square of this divided by this, right? Square of this, right? Square of this divided by this EI. That we have to just take that, right? Then I will get this sum, right, which is equals to 673.7851, right, minus the capital N is what? Capital N means this value, right? So which is equals to what? Which is nothing but the, it is 1, sorry, yes, it is 528, right? This value is what? It is 528. And I will get the value, that is chi-square, that is test statistic. Final answer is what? It is 145.785. Okay, this will be my chi-square, that is my chi-square 2 by 2, which is my test statistic or calculated value, chi-square calculated value. Now just find out this value now. Chi-square alpha, right? Chi-square 0.05, and level of significance is what? Chi-square 4 0.05, right? So after finding this value in the table, you will get this value is equals to what? It is 9.4 something. Okay, it is 9.488. I can easily say that your chi-square calculated value is greater than what? Your table value, right? Now if your chi-square calculated value is greater, then what you will do? You will reject the S naught. And if you are rejecting the S naught, then what means what? That means what? That means these two, right, attributes are dependent on each other, right? That means the programming and mathematics, right? this programming and mathematics. That is the performance of mathematics and performance of programming are dependent. Okay, so this will be your, this hypothesis will be true. Alternate hypothesis will be true. Okay, so this is all about the test for the independence of the two attributes. Okay, so this is our second chi-square test we have discussed. Now the next test we have to discuss is again the test for the just two attributes. Okay, so that we will discuss now. I think this is the last chi-square test. Now after that we will just discuss one more distribution, which is F distribution. Okay, which is last one again, and then we will take again our next lecture of 2 hours in the evening. Okay, right. So the next test I am going to discuss, it is just the it now this is also the independence test for the two attributes, but this is R cross C. That means n number of rows and n number of columns are there. Then I am using this test. But when there is only two rows and two columns, then there is different formula for that. Okay, so that we have to use it. Okay, so the third chi-square test, what is third chi-square test? It is the test for independency of two attribute. Test for the independency of two attributes. Okay, so for that, just consider there are two attributes. Now where I'm considering I have the two attributes, that is A and B. Okay, so I can write the column as it is A1, A2, B1 and B2, right? So I have this 2 by 2 contingency table, and suppose there are some values in this table, which is nothing but the first value is A, okay, B, C and D, right? So from this table, and I have to or we wish to test the independency between these two attributes. Okay, so how we will test that? Okay, so I will just define the null hypothesis in this case. In this case, if my null hypothesis is true, then I can say that the two attributes A and B are independent. Okay, this will be independent if my null hypothesis is true. And what will be my alternate hypothesis then? The two attributes A and B are dependent, right? Two attributes A and B are dependent. Then what will be the test statistic in this case, right? I have to just find out the chi-square, right? Chi-square r minus 1, again it is r minus 1, yes minus 1. That means row minus 1, yes minus 1 means column minus 1. Okay, what is test statistic? It is capital N. Now what is this value? Okay, yes. Now here it is total. Okay, I am finding the total, right? Yes. So what will be this value then? It is just total of these two numbers, right? So it is A plus B. This will be C plus D. This will be A plus C. This is B plus D, right? And this will be my total of all these. That means it is equals to capital N, right? So just I will just use this column, or I will just use this table to find the test statistic. So what will be test statistic? It is capital N multiplied by AD minus BC bracket square. Okay, capital N into AD minus BC bracket square. Just just multiplication of this, right? AD into BC bracket square, and divided by what is your denominator? Just total. Okay, just multiply these all totals, right? A plus B into C plus D into B plus D into A plus C, right? So divided by what? It will be A plus B, C plus D, after that A plus C, A plus C, and B plus D, right? So this will be my test statistic in this case, right? This is my test statistic. Okay. Again, you have to just find out the table value. Now you already know how to find this table value. Okay, it is alpha. It is always alpha in this case of the chi-square distribution. Okay, and we know that that is if my value, that is chi-square calculated value, is less than chi-square table value, then what I will do? I will accept the null hypothesis, right? Okay, so we will just see. Otherwise, I will reject the yes. Okay, we'll see one example on the basis of this now. Okay, so there is one example on the basis of this test, this chi-square test. So, so in a radio listeners, okay, in a radio listener survey of 120 person radio listening, okay, radio listeners survey of 120 persons were interviewed and their opinions about the preference to the Hindi or English music were asked, right? So the results are as follows, right? So firstly, I am considering the two attributes here. That is the type of music and the language of the music, right? Type of the music and the language of the music. So they have the two types, that is the first and second, and the language is Hindi or English. Language will be Hindi or English. Okay. Yes. And the data is given, that is nothing but there are 13%, 45%, 39%, and 23%. Okay, and the question is, they have given you the question, examine whether the preference for the music type is dependent on the language, right? We have to examine, that is music type is dependent, music type is dependent on what? Music is type on dependent on in language, right? Language or not, right? Yes, so simply we can firstly define the null hypothesis will be what? That is the two attributes, that is the two attributes, language, language, and type of music are independent. Okay, language and type of the music are independent. And my H1 will be what then? Yes, it is, that is the two attributes, language and type of the music are dependent. Okay, so this we have to check, right? So simply just use your test statistics. So what is the test statistic? It is the chi-square. So firstly, what we have to find out the sum, right? Now the value of, we know this value, right? A, B, C, D, but we know they don't know these totals, right? And capital N also. So firstly, just find out that values, right? So I will just make again that table. Here it is type first music, type second music. Again it is language is English and Hindi. Okay, these two language I have, and the numbers are what? 13, 45, 39, and 23. Now just find out the total. So what are the total I get here? Yes, what are the totals then? Just find out the totals, row wise and column wise, right? Here the first total will be what? It is, I think, 58, right? 58, and this will be 62. Okay, and here it is 52 and 68, right? So that means there are, so what is the value of the capital N? It is 120, right? Right, so the value of the capital N is 120, right? Now just use the formula, right? So what is your test statistic? Therefore I can say that the test statistic is, what is test statistic? Is chi-square R cross C, which is equals to what? Capital N into AD minus BC bracket square divided by the total of all these, right? That means what? It is 58 multiplied by 62, 52 and 68, right? And this means what? Just cross multiplication, right? This minus this. N is given, that is 120 into 13 into 23, right? So which is 299 minus 45 into 39, so which is equals to 1755. 1755. Okay, bracket square divided by the multiplication of this will become, this will, okay, just find out this multiplication, right? So this multiplication into 68, right? So after doing this all the calculation, you will get this chi-square value, which is 20.0065. Okay, as so this is the value of chi-square 1 by 1. Okay, this is chi-square 1 I got here, and I will find the table value. So if this will be, so what will be chi-square table value then? So this is chi-square 1 0.05. Okay, and this value is 3.841, and you can easily say that my calculated value is what? It is greater than my table value. So what I can say then, I will reject the null hypothesis. Okay, and if I am rejecting the null hypothesis, that means what? That means these two attributes are again dependent. Okay, that is the type of the music and the type of the music and the language. Okay. Right. So here we have covered all the topics of the chi-square distribution. Okay, so what was that? All the topics of the chi-square distribution. The first is for the it is the just a chi-square test for the goodness of the fit. Okay. The second was it is the chi-square test for the independency of the attribute, and the third was the chi-square test for the yes 2 by 2 contingency table. That means what if there are only two attributes are there, right? Okay, if there are only two attributes are there, then we are using that test. That means we are just using that one formula is there. Okay, we will simply that one use that simple formula. Okay, no need in this case, no need to find expected frequencies and that all, right? Here we have to find that all the expected frequencies and all that stuff. Okay, so here we have covered all the things about the chi-square test, right? The t test is also covered, right? Now the